Okay, fourth period, this is for you. I'm going to go through what we went through at the end of class. We did it really fast, so I want to make sure you know what you're doing. First of all, when you're doing half-life, there are two formulas. The first formula is to figure out the number of half-lives that have been spent. That's why it's N for number. Number of half-lives. To figure that out, you need to know two kinds of time. The first time is how much time has elapsed since the beginning, whatever the beginning was. The second one is the time for one half-life. You need to know those two things in order to figure out N. You need to know N because that is the exponent here in this formula where you need to know the amount remaining, and then that equals the initial amount times 1/2 raised to whatever N happened to be. So you got to solve this one first, find N, and then put that in here, and you're either going to solve for this or solve for that. So let's try the first one. How much gallium-72 is left in 15.25 gram sample after 28.2 hours if the half-life is 14.10 hours? So let's identify what we have here. First off, how much is left? So we want to know initial amount. I'm sorry. We want to know amount remaining. Oh, okay. If we want to know amount remaining, we need to know everything else. 15.25, that's our initial amount. 28.2 hours, that's our time elapsed, so lowercase t. 14.10 hours, that's our capital T. That is our time for one half-life. So let's fill this in. Our number of half-lives equals 28.2 hours divided by 14.10 hours, and that'll give us a half-life of 2. 28.2 divided by 14.1 is 2. So then the amount remaining equals our initial amount, 15.25 grams, times 1/2 raised to the 2. And if you do that, so basically it's 15.25 divided by 4, because that's 1/2 to the 2 is 1/4. That will give you, I just want to make sure I get this right, 3.81 grams. You got to round to 3 sig figs, because this number has 4, that number has 3, this number has 4. We go with the fewest, which is 3. All right, next one. If this many grams of neptunium is left after 11.73 days, how many grams was in the original sample? So this time, we know our amount remaining. And we want to know what is our initial amount. So therefore, our amount remaining equals our initial amount, which we don't know, times 1/2 raised to the n. So let's figure out what n will be. N is, we have to figure out of these two numbers, which one is our time elapsed and which one is our half-life. So after 11.73 days, that's our time elapsed. The half-life is 2.346 days, so that's our capital T. So 11.73 divided by 2.346, that gives us an N of 5. So then we're going to put 5 in here. So we have 0.0034 equals IA times, and 2 to the 5th is, where's the calculator? 2, and use the little caret button. So to find out where that is. Okay, where's 2 to the 5th? 2 is 32. So 1 over 32. So then we divide both sides by the inverse of 32. So basically we're multiplying this by 32 times 32, oops, 32. And that'll give us our answer of 0.107 grams is our initial amount. Okay, the last one has a little trick only because of conversions. Notice, okay, here's our grams. So how much is left in that sample? That means we want to know, again, amount remaining. So this is our initial amount. Our time elapsed is 4 hours, but the half-life is 15 minutes. Can't do hours and minutes. So we have to convert minutes into hours or hours into minutes. Personally, I prefer to convert down so that your number gets bigger instead of smaller. So 4 hours. Here's a little doohickey. 1 hour, 60 minutes. 4 times 60, 240 minutes. Okay? So then we can put that in for our n. So after 240 minutes, if a half-life is 15 minutes, so 240 divided by 15 is 16, so n equals 16. So our amount remaining equals the initial amount, which is 93.1 times 1/2 raised to the 16th. And so again, if you go through that, you'll get an answer of 0.00142 grams. So grams is always the unit because we're talking about mass. And then we want, again, 3 sig figs because there's 3 here, and 3 here, so there's 3 there. And I forgot to mention sig figs up here. There's 3 sig figs in this number, 4 in that number, 4 in that one. So we go for 3, that's our fewest, so that one's also 3 sig figs. So that is how to do the half-life problems. And then the last thing we talked about was the periodic table. Okay, so on your periodic table, you have period numbers written on the side. These are the period numbers. Because periods are in rows, they go like this. And then on the top, these are the family or group numbers, depending on how you call it. And so, because families and groups go like this. So if we wanted to find the period and family of any element, first we have to find the element on the periodic table. Phosphorus is right here. So it's in period 3. It is in family 5A. The V is the Roman numeral 5. Beryllium is in period 2. And in family 2A. Neon, right here, period 2 also. But now it's in family 8A. Zirconium, number 40, is in period 5. Now it's in family 4B. Iron is in period 4. And it's in an interesting family. If you notice right here on the periodic table, this one Roman numeral covers these 3 columns. I call this the triple wide family. So iron is in 8B. These guys end in A, so they're representative elements. These guys end in B, so they're transition metals. We also have some special names for some of these. You may recall that family 2A is called our alkaline earth metals. Please make a distinction between alkaline metals and alkaline earth metals. If you're writing on the test and you write the wrong one, you're not going to get credit. Neon is in our noble gas family. And as we said before, these guys are transition metals. That's not in a particular special family, it's just a non-metal, because it's to the right of the stairs. And then the last thing in the notes was I give you 4 elements, and then you have to choose which element's going to react like that. So if it's sulfur, you're going to choose somebody else in the sulfur family, which will be oxygen. Xenon, the only other one in the noble gas family there would be argon. Iron, as I said, this is in a special family, so it's going to be in cobalt, is in the same family. And then carbon is in the same family as silicon, so they're going to react the same way. And that's it. That's the end of the notes. Thank you for being so attentive during class. I realize it was really rushed, but I hope you understand.